Hey there, Mr. Weaver here, and this is Geometry Lesson 6, Volume. After this lesson, you need to be able to answer questions involving the volume of cylinders, cones, and spheres. You'll know you're successful after this lesson if you can calculate the volume of circular objects, including cylinders, cones, and spheres, both in context and out of context. So let's start with what is volume? So volume is the amount of space that it takes up. Many people also say that volume might mean the same thing as capacity, which is the amount of substance an object can hold, but volume is the amount of space that an object takes up. Either way, we're going to use the same formulas to figure out volume, if it's space or how much it can hold. So let's get into our three objects. First, we have a cylinder. Our cylinder only needs two things to figure out the volume. The radius r, so the radius of the circle, that is halfway across the circle. And it also needs the height. Now, here I put height in quotation marks because it's not necessarily always how tall the cylinder is, because if the cylinder was tipped on its side, then it would be how long the cylinder is. So either way, it's how far it is from one of the circle bases to the other circle base. And our last letter in our formula there is V. V just stands for volume. So you're either figuring that out, or if it gives you the volume, that's where you plug it in. The other symbol there is your pi symbol, which is what we'll type in the calculator and then decide if we want to leave it or round off. Our next object is a cone. The cone has a very similar formula to a cylinder. The only difference is that it is multiplied by 1/3, or I might write it as divided by 3. They both do the same thing. So volume is equal to 1/3 times pi times r squared times h. You still need the radius, which is halfway across the circle, and you need the height of the cone. And our last object is a sphere. Again, we have a fairly similar formula. This one does not involve the height, but it involves multiplying by the radius a third time to the third power. So we have the volume is equal to 4/3 pi times the radius to the third power. And we can see in the picture where the radius might be located, from the center of the sphere to any of the edges. In this lesson, for the examples, I'm going to do one of each type of object before I have you practice any. So let's start with a cylinder. What is the volume of a cylinder with a radius 5 units and a height of 12 units? So for this, I am intentionally drawing the cylinder tipped over on its side so we can see how the height is not necessarily how tall the cylinder is. So the radius halfway across the circle is 5, and the height is 12. So in this case, it would be the length of it was 12. To figure out volume, I just plug in the numbers and calculate it out. So I'm going to plug in 5 for R and 12 for H. If I continue to multiply it out, 5 second power is 25, and then 25 times 12 is 300. So the exact answer for my volume is 300 pi. If you leave it with the pi symbol in there, it gives you the exact answer. So similarly, if it asks you for the exact answer, you need to leave the pi symbol. If it asks for an approximate answer, that means to multiply it out, where you get a decimal. So our approximate answer here is 942.48. Our next example is a cone. So a cone has a volume of 24 pi units cubed, and the radius is 2 units. What is the height? So here's our cone. we know the volume is 24 pi, and we know the radius is 2. We want to figure out what the height is. So just like before, we're going to use the formula, but this time for a cone, and we're going to plug in the values that we know. So we know that V is equal to 24 pi, and R is equal to 2. So I'm going to plug in those two values. Then I'm going to work through and solve for H. So 2 to the second power was 4. Now, to get H by itself, I would need to multiply both sides by 3, divide both sides by 4, and then divide both sides by pi. What I end up with is the height is 18. To double check this, we could substitute 18 back into the original formula with 2 as our radius, and we can see if we come up with 24 pi as our volume. If we do that, yes, that's what we get. So 18 is our height. Our next example is a sphere. So some information is given about each sphere. Order them from least volume to greatest volume. You may sketch a sphere to help you visualize if you prefer. So for this, we need to figure out the volume of each sphere and then put them in order. Since they're all spheres, we're going to use our formula volume equals 4/3 pi times r to the third power for each one. Sphere A has a radius of 4. So I'm going to plug in 4 for r and calculate it out. 4 to the third power is 64. If I multiply it out and get that approximate answer, so I multiplied it out with pi, I get approximately 268.08. So I'm going to mark that as the volume of sphere A. Sphere B has a diameter of 6. It did not give us the radius, but the diameter is related to the radius. It's just all the way across the circle instead of halfway. So if we know the diameter is 6, then the radius is 3. That is what we need to plug in. So I'm going to plug in 3 for r. If I do that and calculate it out, the volume of sphere B is about 113.09. So already I can see that B is less than A. Sphere C tells us the volume is 64. So I don't need to do anything. I know the volume is 64. And then sphere D has a radius double that of sphere B. So if the radius of B was 3, then the radius of D is 6. Plug it in. The volume of sphere D is 904.77. Now we need to put them in order from least to greatest. So the least volume was C. The next lowest was B at 113. Then A at 268. Finally, D, 904, has the largest volume. In Desmos, if you type in your formula for either your cylinder, your cone, your sphere, and then just change what you need. So in sphere D, in the last problem, I know that the radius was 6. It calculates it out for you. V is equal to 904.78. Don't worry when you type it in about the graph. Just worry about there. Now, if it gives you the volume, so in one earlier it was 24 pi, and you needed to figure out the height, it won't do that for you. But if you need to figure out the volume, you can change R and H to the values that you need, and it will calculate it out for you. Now that I've done the 3 examples of each type of object, do the 3 problems on the student does side. Pause the video, calculate the volume related questions for the cylinder, the cone, and the sphere. Let's check. In the first one, you should have found that the radius of the cylinder was about 4.4. Here's how to get that. We start off with our volume formula for a cylinder. We know the volume was 175 pi, and we know the height was 9. We need to solve for r. So I'm going to divide both sides by pi, and then divide both sides by 9, and I get r squared is equal to 19.444. Just like we did with the Pythagorean theorem, if I want to solve for a variable to the second power, I need to take the square root of both sides. So the square root of 19.444 is 4.409, or about that. Let's check the second one. Which cones have the same volume? So you should have figured out that A and D are the ones with the same volume. Each time you're using the formula volume equals pi times r squared times h divided by 3, or the 1/3. Cone C is already given to you. So if we figure out cone A, B, and D, A has a volume of about 50, B has a volume of about 37, C is already at 64 before we even multiply it by pi, and then D is at 50 as well. So A and D are the two that are equal. Finally, what's the volume of a sphere with a radius of 3? You should have found that the exact volume was 36 pi, or if you approximated it, multiplied it out and rounded off, you should have got about 113.09. To get there, radius is 3, so take the formula for a volume of a sphere, plug in 3, multiply it out, and those are your answers that you get. In this lesson, we learned that volume is the amount of space that takes up, but can also be used similar to capacity, which is the amount that an object can hold. We learned that there were 3 objects that involve circles: cylinders, cones, and spheres. And they all have similar formulas that involve the radius, pi, and then cones and cylinders involve the height, whereas the sphere involves the radius a third time. By plugging in values for the required dimensions of the objects, we can calculate the volume of that object, or if we were given the volume, we could plug that in and calculate other missing dimensions, such as the radius or the height. Either way, the trick to the volume is knowing which object you are trying to calculate the volume of and choosing the correct formula that goes with it. So, after this lesson, do you now know how to calculate the volume of circular objects, such as cylinders, cones, and spheres? If you're not comfortable with all 3 of these, go back and watch the examples for the specific object to deepen your understanding of the concept. And that's the end of lesson 6 on volume.